Let's review my example solution for day 6's assignment. Our gatherMessages function is the main part of the assignment. So how could we have returned an array of messages in the same order that they arrived when we had a random delay become involved? You may have been tempted to use promise.all here, but this would have caused you some problems. While promise.all will return results in the same order in which the promises were supplied to it, promise.all does not guarantee the order in which the promises are executed. Because the return message function remembers the order in which it's been called, and its output is affected by that order, promise.all will have given you inconsistent results. To guarantee the order of execution, we can make use of the modern for-of syntax and await return message to complete every time we iterate the input messages. Then we push the results onto an array and return that array at the end of our gatherMessages function. If we try running our code, you'll see we get back an array containing A, AB, ABC, no matter how many times we run it or the length of the delays between the messages, as defined by this random function here. Writing an appropriate unit test should be relatively simple. Mark the test as asynchronous by using the async keyword, and then simply await the output of the gatherMessages function. Pass the result to expect and expect the appropriate output. We'll try running this unit test now of the gatherMessages function. Here we can see that the unit test passes. So all we've done is awaited gatherMessages by passing in the messages, and then we expect it to equal A, AB, ABC. This assignment should have helped you increase your familiarity with writing async functions and how to correctly order data that is output in an asynchronous manner. This can come in useful when you're calling remote endpoints, APIs, that are affected by the order in which they're called. This will also have helped you write unit tests that run asynchronously, which is essential when you're testing async code. Section 7. Putting it all together. Authentication in Express using Passport. Now that we have all our basics for writing a Node app, we're going to need to expand our knowledge to make our API a little more secure. There are a few ways to get authentication working in Express, but by far the simplest is to use the Passport middleware. In this video, we'll cover getting started with Passport, using Postman to call our API, and setting up the bearer token strategy with Passport. Passport is an authentication middleware for Express. It provides its functionality via modules known as strategies, and it's up to you to pick the correct authentication strategy for your application. Some strategies are better suited to different application types. There are strategies that common OAuth providers like Facebook or Twitter provide, or strategies that support using a simple. Some strategies are better suited to different application types. There are strategies that common OAuth providers like Facebook or Twitter use, or strategies that support using a simple shared secret. We'll pick a strategy later, but for now, let's get the basic Passport package installed and set up. First, we need to install Passport using npm install passport --save. Once that's done, we can require Passport into our app. As Passport doesn't use the debug module that we've used elsewhere, we'll also configure a new instance of debug right now so that we can do our own logging. And then finally, we need to tell our app to initialize Passport. This won't have made any visible changes to our app yet, as we need to specify our strategy and alter our routes, but we'll cover that later in the video. As the application we've been building has been an API for a library, we really need a more suitable method of communicating with our API rather than using curl calls or the browser. Postman is a specialist application that runs on Mac, Windows, and Linux and enables us to craft API requests and examine their responses. We'll be using Postman from now on, so make sure to get it installed and running. Let's start our app and then try calling our API using Postman. Let's enter the URL and an endpoint. Here we can see the response that comes back. It's formatted it because it's recognized it's a JSON object. We can also see any headers that came back. So here we can see the headers the Helmet middleware has set to try and improve the security of our API. We can also set up authorization here. We'll get to this. We can also set up custom headers if we wish. For requests where we can send data to an API, we can also fill in the body of a request here, either with key value pairs or some raw JSON data, for example. Now that we've set up Passport as the authentication middleware for our app and seen how we're going to call our API with authentication using Postman, now we need to configure the authentication strategy we wish to use. As our API is relatively simple, we don't need to uniquely identify different users, so we're just going to use a shared secret via a bearer token. By simply setting the authorization header to contain this token, we consider an API user to be authenticated. This is by no means secure, and you should investigate a different and more appropriate strategy for your own applications. Let's get started by installing the correct Passport strategy. So we're going to npm install Passport HTTP bearer. Now we need to require that strategy into our app. And then configure Passport to use the strategy. We pass the bearer strategy to passport.use and then provide a callback method. This callback is called every time Passport wants to authenticate a request. Passport provides us with the authentication details that the user specified, and then it's up to us to call this done method to say whether or not these details are correct. Let's log the details that are provided. And call the done callback. We use null as the first parameter to indicate there's no error, and then false as the second parameter to indicate that authentication has not been successful. Now that Passport is configured with the strategy, we need to tell Passport which routes we want to be authenticated. We do this by changing our routes, so really we're actually telling our routes to expect authentication, not the other way around. First, let's require in Passport. By inserting the Passport middleware between our route path and route handler callback, we essentially hand off control of the incoming request to Passport. Our route handler will only be called if authentication is successful. First, we tell Passport which strategy to use, and then we pass any options for that. We don't need session support for bearer tokens, so we're going to turn that off. Let's restart our app and try and hit this route. As you can see, we got a 401 unauthorized response. Let's head back to our bearer strategy configuration, and we're going to set up a check for the bearer token. So, if the token matches a particular string, then we'll call the done callback with null to indicate no error, and then an empty object to represent the user that's authenticated. We're assuming that everyone is the same user, so we don't provide any real data. We'll restart our app. Now again, we can send this request. It will come back as unauthorized. We need to set up our authorization bearer. Select bearer token and fill in the token details. Once we send the request again, we get a proper response this time. If we look in headers, we can see that the authorization header was generated for us. Filled in here, bearer, and then the bearer token. So that's great. We're getting our data just like before. If we look in our logs to turn on logging, we'll hit that route again. If we look in our logs, we can see here the logged secret from this line.